We live in a world full of mixtures, and yet we hear a lot about purity. But what does it mean if something is pure? In the eyes of a chemist, purity is absolute. It's not a feeling, it's a fact. This is the science of purity. Purity is a concept we tend to hear a lot about, particularly in relation to our food and drink. But when chemists use the word pure, we mean something very specific. When a chemist says a substance is pure, they mean that it consists of only one type of chemical substance. And that is something that is not obvious when we observe things in the world around us. For example, I have 3 glasses of what we could reasonably call water in front of me. The first is taken from my garden pond, and even at a glance, I can see it certainly isn't pure. I mean, there's bits floating in it and everything. It's clearly water mixed with something. And that's the key word here, by the way, mixed. Mixtures of anything cannot be pure, as by definition they are at least 2 different chemical substances physically combined together that have not reacted to form a new chemical. So what about these 2 glasses? I mean, they look pure. However, with just a sip from this one here, I can tell you it's got some salt dissolved into it, so it's clearly a mixture. Actually, that was really salty. Things I do for science. This one, however, tastes great. It's a really refreshing drink. In fact, there's nothing my taste buds can tell me that there's anything in there other than water. However, it came from this bottle here. And with just a quick glance at the label on the back, I can see that in fact there are several substances dissolved into it. So while it's perfectly drinkable, it does not meet the chemical definition of pure. So what would a glass of pure water be? Well, it would only have water molecules in it. That is, only molecules of H2O. More on that specific example later, but how could I tell if a substance is pure? Well, every substance has at least one temperature where it changes state. Now, that's usually a melting and a boiling point, but occasionally it might be a sublimation point where it changes directly between a solid and a gas. The thing is that pure substances do this at very clearly defined temperatures, which are known and can be checked in tables where they're listed under specific atmospheric pressures. They also stay at that temperature until the change of state is complete. So, we all know that water boils at 100 degrees centigrade, right? Well, let's be specific. Pure water boils at exactly 100 degrees centigrade at standard atmospheric pressure here on Earth. So how would I check that? Well, let's have a look at some equipment. As far as a GCSE exam answer goes, the way to check if your water sample is pure is to put it in a boiling tube, add a thermometer, and then heat it until it boils. So let's have a look at that in the lab. First, my Bunsen burner is lit and set to a blue flame, and then it's placed underneath my boiling tube. With the flame transferring energy to my water, the temperature quickly rises and small bubbles form as the temperature approaches 100 degrees centigrade. The water now begins to boil and the temperature remains fixed at 100 degrees, where it will remain as long as there's water left in my tube. It's worth noting that it can be tricky to get such a small volume of water to boil gently and continuously, and so you might have noticed that I had some anti-bumping granules at the bottom of my boiling tube, which is a useful practical tip. In actual fact, this equipment here probably wouldn't pick up very small levels of impurities, such as those as we might find in that bottle of mineral water. To find those, we would probably need high-end laboratory techniques, such as an HPLC machine combined with a mass spectrometer. But in terms of your chemistry exam, the examiner would like you to talk about the method we've just described with this equipment here. Can we actually get pure water? Remember, we would need only H2O molecules in our glass, with no other substances mixed in at all. It's certainly a theoretical possibility, but it would be almost impossible to reach that standard in a glass of water. I've already talked about the fact that it's hard to judge whether a substance is pure or not with our limited human senses anyway. But from a theoretical point of view, what sort of things could be pure? Well, the first and most obvious is the elements. These are, by definition, one type of atom, and so fit our definition of purity. Any chemical compound, such as water, ethanol, sodium chloride or magnesium carbonate, can all be chemically pure. But some chemical knowledge is required to know about their structures and their bonding. This is something you'll develop during the whole of the GCSE course and over the entire set of videos on this channel. But let's look now at some common misconceptions about purity, which the examiner may choose to test you on in a GCSE exam. These substances, let's be clear, are not pure and never can be because they are mixtures. Air, our atmosphere, is a mixture of mainly nitrogen and oxygen gases, with small amounts of others, so is absolutely not chemically pure. Seawater. Now that's several different salts and other compounds mixed together, and so again, it cannot be chemically pure. Crude oil. Now this is a complex mixture of many different hydrocarbons, again, not pure. Fruit juices. Now, the manufacturer might call these pure, and in the context they use the word, they mean it's freshly squeezed from fruit. But as a chemist, this is a complex mixture of sugars, vitamins, minerals, and water. It's anything but pure. And finally, watch out when the examiner mentions alloys. These are solid-state mixtures of metals and non-metals, and include such things as brass, bronze, and steel. None of these can be pure. So, let's look at some exam tips. If you were asked to give an example of a pure substance by name in the exam, state an element. That's always a safe answer. A single named chemical compound, such as sodium chloride, sulfur dioxide, calcium carbonate, are all easy to name on the spot, or easy to spot if you've got to pick them out of a list. Mixtures. If making a suggestion, I say use salty water or crude oil, and that will sort you out. But if you're asked to spot mixtures from a list, probably they're going to use those ones that I talked about in the misconceptions earlier. So learn those and then you'll be ready for the exam. Finally, the examiner may ask you for a definition of purity. Remember that if a substance is pure, it contains only one type of chemical compound or element. It will have a stable melting and boiling point as well, and that is your best indication that the sample is pure. Until next time.